I've prepared a mathematical Amouse Bouche. We will go through some magic tricks, through a puzzle, and at the end I'm going to show you an impossible looking object. All of these ideas revolve around the same concept, but we'll get to that in a moment. To start, I would like to start with the Carabiner Puzzle. And for the Carabiner Puzzle, you'll need at least one Carabiner. I have 3, so I'll use the 3. The idea is to have all 3 round objects. If you don't have a Carabiner, you can use a ring. But the idea is to have all Carabiners put together in such a way that no 2 of them are linked, but all together, no matter how much you shake, you have one object that stays together. I'll give you a moment to think. If you're watching this live and streaming, you will have to think quickly. If not, you can pause the video here and go at the problem. I promise you I will not give the solution anyway. Well, you might get to an idea in a moment. Now, moving on. I will need someone from the audience. Ah, you, madam. Could you lend me your fingers? Perfect. I'm going to use a ring, which I showed you, and a chain. And I'm going to place the ring and the chain on the fingers. And as you can see, the ring does not come off your side, my side, the top, the bottom, this side, or that side. Left or right, depending on where you're standing. Now, I'm going to twist, and I'm going to turn, and as you would expect in a normal magic trick, the ring does come off. And this is the part where we applaud our volunteer, thank you very much. And the magician, no, you don't have to applaud, thank you. I will not hear it. Now, this trick is 500 years old. If you haven't figured it out, it's in the books. Moving on to a newer one. I'm going to use 2 rubber bands, and I'm going to place one rubber band so that it holds the other band in place. Right? The white rubber band does not come off the bottom because the green one is holding it, and the green one doesn't come off because, well, my fingers are holding it. If you look closely, yes, the green rubber band doesn't come off because the white rubber band is holding it, and the white rubber band doesn't come off because my fingers are holding it. Well, you might notice that the green one and the white one are pretty much exchangeable, and my fingers not so much. But to finish with one last magic trick. I will need a loop of string, a perfectly looped off string. And how do you know it's a perfectly looped off string? Well, it doesn't have any ends. It's because I glued the ends together. Now, if I clip one of the carabines from early on so that it holds these 2 ends, that wouldn't do much because as soon as I release any of the looped part, the carabiner falls off. So to prevent this from happening, I'm going to place another carabiner to hold the top 2 bits of loop. And as you can see, both carabiners are orthogonal to each other, right? They make a right angle. And you can see that the blue one doesn't come off the bottom because there's a green carabiner holding it in place. And the green one doesn't come off the top because there's a blue one holding it there. Now, if I were to clip them together, you might already have guessed it. What would happen? Well, the rope would come straight off. Strange, isn't it? And finally, our Amouse Bouche ends with an origami object made by a good friend of mine. Not his design, but it's a very beautiful object for me because it is made with sheets of sheet music. And you can see that there are 3 different rings because he managed, or he actually did go through the trouble of coloring them in. So there's one which is yellow, there's one which is blue, and there's one which he didn't color. And you can see that all of them are linked together. Now, we get to the part where we get to the mathematical object. I've shown you multiple things, but all of them are linked, pardon the pun, because of this mathematical object, which is called the Boromian Rings. Well, the Boromian Rings, they are called after the Boromian family from Italy, somewhere in the medieval ages, and they had a very beautiful banner where they had three rings linked together in a very specific fashion, which is that no two of those rings are linked together, like in the puzzle, but all three of them are clasped together. And actually, this is a design not from Italy, but we kind of use their name. But the Vikings did it. We have many references from India, from Japan. Well, basically everywhere where people could think of rings and how to link them, people would think of that. I have here a small model I made from rope. I hope you can see it well. I'm going to move closer, and you can see that there's a blue piece of rope which goes around here. There is a yellow piece which goes around the blue one, and there's a white piece which goes around the yellow one. Now, this is a mathematical object, like I said, the Boromian Rings, and they are part of a big family of objects which are called sometimes I am not able to pronounce things properly. Brunion Links, with a Portuguese accent, sorry for that. And this was a mathematician that somewhere in the late 19th century wrote about these ideas and created the mathematical theory behind of them. Well, what's interesting about these Brunion links is that you have structures like previously. Remember the big loop of string? Well, let's just shrink it to a small one. And let's place the carabiners exactly as we did. One here, holding the bottom. One here, holding the tops. And as you can see, the green one doesn't come off, the blue one doesn't come off. But if we pull the rope as it is right now, we get this exact same structure as we've seen in the small model I glued. You have these carabiners being each free of the other, and this rope being free on its own. But as soon as you link any one to any one of the others, the last one falls out. Now, this is the whole idea behind all of the things I showed you, and you're left with the puzzle of the carabiners, and you're left to figure out a little bit about what happened with the magic. Thank you very much. I'm Tiago. See you next time.